30 seconds here. Okay. Check your answers with mine to make sure you have something along those lines. Obviously, it does not have to be word for word, as long as you had something along the lines. If you put switch x and y, fine. And then if you put solve for y, fine. And then if you put change the notation, that's okay too. You don't have to be exactly like mine, but as long as you get that idea that you have to first switch the x and y, solve for y, and then make sure it's in function notation, okay? So something along those lines, like I said, does not have to be exact. As long as it is meaning the same, then we're good. Yeah, 30 seconds to make sure you got it. Like I said, you might need a graphing calculator today, so if you need one, make sure you grab one. So, looks like everyone's done writing. Let's go to this very first one. We're just going to practice what I just said. But now we're going to be working with things like a cubic or a radical, which we haven't really done before in this class. So, the first step, we're going to do what? Yeah, switch x and y. So here's x. Then I got equals 5. I'm just going to show you in purple here that that's what I'm doing. I'm switching x and y. Switched x and y. Now I have to solve for y. You want to get y alone. And I know that's hard for some people because you're so used to solving for x and it's hard to break the habit. And actually what we see on tests occasionally is that you'll get almost to the end, but then you go reverse. Okay, just because you're just so used to that habit. Hopefully that doesn't happen to you. Okay, so we're solving for y. So if you have a highlighter, I just like to note that that's what our goal is, to get y alone in that highlighting portion. So what would I do to both sides first? Yeah, I would add 4. And again, I'm just weird. I put the 4 off away from the x because somehow some people, I'm trying to like show you some errors that happen, is people will put 4x. I don't know why, but I want to make sure I put it off to the side because I can't combine those two. So I have x plus 4 equals 5y plus 2, all cubed. Now, this is where some people get a little confused. In order to solve for y, I must first get rid of the big group. How do I get rid of cubed? Cube root. Very good. I must take the cube root of both sides. Okay, they're inverses of each other. X cubed and the cube root are inverses of each other. So I'm going to go ahead and do that. So I'm going to take that cube root of both sides, and that cancels that out. So you can see that. Okay, so then I have the cube root of x plus 4 equals just that 5y plus 2. Okay. And we're not solving for like an answer. We don't want a solution. We just want to find the inverse function. So now when I'm solving for y, what would I do next? Minus 2. And again, I'm just going to go all the way off to the side there because very common is people will go 4 minus 2. Well, that 4 is inside the radical. You can't do that. So I have the cube root of x plus 4, all minus 2, equals 5y. Last and final step for solving for y is, divide by what, sorry? 5, very good. And the whole thing is divided by 5, not just one piece. So right away, I got y equals the cube root of x plus 4 minus 2 all over 5. Done with step 2. The very last step, there's really no math involved. I just need to make sure that I am noting it is an inverse notation. So I'm just going to be changing my y to f of x. What'd you say? Do you have questions on any piece of that that you would like me to explain again? Okay, that is now your inverse function. We went from a cube root, we went from a cube to a cube root. That's a great way for you to check your answers. Look at your original equation. It said cube, so you better end with cube root. If I said squared, you better end with square root, because that's the inverse of a cube. That's the inverse of a cube. Okay? So try to use that to help you when you do some of these problems. Okay? All right. You could keep going. You could break it up. You could have 1/5 radical 3 x plus 4 minus 2/3. That's fine. You would have to be able to identify that sometimes and make sure that you can go back and forth. Okay. All right. Let's look at this next one. Ooh, I wrote really big. This one's easy. It's linear. So you do this one because you've done this one before. Linears are pretty easy and pretty straightforward. Please let us know if you have any questions. As far as you can, switch x to y, solve for y. A lot of you are flying through, that makes me happy. Remember, when you have a fraction, you need to multiply by what is called the reciprocal. Right? To get rid of a fraction, you have to multiply by what's called the reciprocal. When you are done, you have to look up. Don't look at mine until you finished yours. And if you left it as 2/3 parentheses x minus 7, that's not technically wrong. So that would be okay. But I just kept going. I like to keep it in simple form. Give you another, make sure that you understand what's going on.
The math brain thing is not finished.
Yes. Yes. So what I mean by the reciprocal, that's why if you forgot that, you just couldn't remember, and that's okay. Make sure you make a note then, and maybe circle it or star it, and make sure that you understand that when you have a fraction, to undo it, you must multiply by the reciprocal. 3/2, the reciprocal is 2/3, because you just switch them. Okay, do you have questions on that? Okay. All right, this one, we're going to do together because we haven't done this type of one yet. Now remember, I am starting with a cube root, so what should I end with because I'm looking for the inverse? What'd you say?
Cube root.
Yeah.
I'm starting with cube root, so what's the inverse of a cube root? We did it in the first problem. Cubed. So maybe make a note. Whenever you have something like a radical, like to the end, I'm just put the n in the index there. Let's just say I had this. The inverse will always be x to the n. Always. Like if I had the 4th root of x to the 4th is the inverse. If I had the 5th root of x to the 5th is going to be the inverse of that graph.
And you can go backwards as well. If you have
There you go.
x to the 5th, the inverse would be the 5th root of x.
So I'll do this little, there you go. And go back to my math days and be like, if and only if. I think Ms. Markovitz is probably the only one that knows what I'm talking about. Okay, so let's go ahead and solve for this. So I first switch x and y. Okay, that's all I did for that very first step. I switched the x and the y. Okay, what must I do next? Yep, I subtract 1, so I'm going to get x minus 1 equals 2 times the cube root of y plus 5. And the reason why I say that in my head, 2 times the cube root, is because I'm about to take the inverse of that. What's the inverse of doing 2 times something? Dividing by 2. Very good. Okay, so because again, our goal is to get y by itself, and if it helps you, highlight y so you know that's the goal. The goal is for you to get there. So now I have x minus 1 all over 2. These cancel. The cube root of y plus 5. Now we're back at that situation where we kind of were doing an 8a. I have this whole thing under the radical. How do I get rid of cube root? I cube it. Thank you. Yeah, you guys are picking that up. Awesome. So in order to get rid of a cube root, I must then cube it. That cancels. So now I am left with x minus 1 all over 2 cubed equals y plus 5. Last and final step here is to do subtract 5. And this is what I'm going to do again. I'm going all the way off to the side only because, I mean, obviously some of you do not need to do this, but some people like to subtract that negative 1 minus 5 because they think they're like terms, but they're not. Okay, so then I have y equals, sorry, I write really big, x minus 1 all over 2 cubed minus 5. That is the inverse. And you can kind of talk to yourself and say, well, I started with cube root, I ended with cube, I'm good. Last and final step is just to make sure it's in that inverse notation. So I have f negative 1 of x equals x minus 1 all over 2 cubed minus 5. When you're ready, flip the page. The cube root?
Yeah.
No, they're different. Yeah, so the cube root and the cubed are different. So like 2 cubed is 8, but the cube root of 8 is 2. Okay, so those would be inverses of each other. It's a good question, actually. Okay. Now, this next one. Oh, it's really hard to close that. Yeah, it's really hard to close that window. So it says, sketch a graph of the original function, find the inverse algebraically, and then identify the requested information. This one's going to be a pretty easy one because we're talking about cube roots, and cube roots are easy. Now, do you remember what a cube root kind of looks like just based off of what we learned last semester? Does it have the same end behavior or opposite end behavior? Opposite. So remember, we're kind of just thinking about cubic. You don't have to write this, but just kind of note to yourself. A cube is going to look something like this. It's got like a little snake thing going on. Okay, it's positive leading coefficient in the front, so it's going to be going that way. Obviously, you can type this right in your calculator, but I'm trying to get you to do as much stuff as possible without a graphing calculator. Okay, so when we're sketching the graph, either plug in your graphing calculator, so take a second, go to y equals and plug that in, and kind of get some points to plot on there. Or if you know that this, does anyone know, here's a challenging question, where my inflection point's going to be? If you remember what an inflection point is. This is from last semester, it's kind of way back.
2, 3.
It is 2, 3, very good. Again, something from way back, but it's called an inflection point. So this point right here, where it starts to change directions, well, technically a normal cube root doesn't, but that inflection point is going to be at 2, 3. So naturally, I would go 1, 2, up 3. But your graphing calculator could tell you that as well. What was another point that you found on the graph? Did you find anything for 3? Yeah, 3, 4. And then did you find anything for 2? 1? Yeah, 1, 2. And again, kind of what I told you, it looks like this, of some sort. I'm not asking you to be perfect, but it's nice to get some points so that you can have that to go off when you graph your inverse.
I'm also going to tell you guys, on the test, there's a non-calculator portion for this chapter, so make sure you do know what some of these graphs might look like so you can have that idea of a sketch in your mind, okay?
Okay. All right, next step is to solve for the inverse. I want you to do that now because we just did this type of problem on 8C right here. So go ahead and take a second, This problem right here, nope, I lied. This problem right here, 8A, we just did something like that. So I want you to take a second with your group or with yourselves and see now if you can do it. Because we did it together. Now let's see if you can do the solving part. Well, it does, but on the other side. So like if I, I'm just gonna go on this side here. If I had y squared equals 4, what would be the answer?
What's the inverse of cubing something?
That's why I feel we're actually gonna do that together. And just 2. Can I put negative 2 in there?
So let me ask you this, what's the inverse of squaring a number? Y. So x squared, x to the power of 2. We talked about it yesterday. Cube root? Yeah, that thing.
How you doing? And this stuff is tough. Oh, you guys are getting it. Yeah.
No. And the buttons.
You guys are geniuses.
Right here, right? What's this in blue? What is this thing of the square root? Square number is the inverse of square root. Cube number.
Oh, this is supposed to be up less. It was really late at night. When you are done, look up and make sure you did it correctly.
What is your declaration? Y. What's the inverse of add it? And that plus 2 be outside of your cube root.
Walking around, you guys did a fantastic job with that, so good job. Now, when you take a cube root of something, remember, it could be plus or minus. You can have plus or minus under the radical, so it's okay to have that. Now let's talk about the graphs. We have these points and we can graph the inverses of them then. So if I have 1, 2, up 3, what is my inverse point then? If I have 2, 3, what's the inverse? 3, 2, so 1, 2, 3, up 2. Okay, if I have 1, 2, then what's the inverse? 2, 1, and then if I have 3, 4, what's the inverse? 4, 3. Okay, now here's the tricky part. Knowing where the arrows go, because some of you I feel like want to just draw it just like we just did. Okay, but if you actually take a second and put in your graphing calculator what your inverse looks like, you would actually see that it does not go the same direction. Okay? Does anyone know what direction does it go? Does it go up and down or does it go left and right? Left and right, very good. Okay, so it's going to look something like this. Now, again, you could always check that with your graphing calculator in the beginning. Hopefully you start getting better at it. Now I want to show this to you one more time because I want to make sure it's drilled in your head. Yesterday for homework I asked you what is the symmetry line. What was it? Yeah, y equals x. And if you notice, mine's not perfect, so my graph's not perfect. If I take this arrow right here in blue, I grabbed it and I flipped it over. It's going to end there. Okay, so it's kind of cool that you can see that and you kind of make that assumption there. Same thing with this one in pink. If I take that arrow and I flip it over that y equals x line, you should end up in that location. So make sure that you're able to check your answers like that. Okay, now let's talk about these. Do they forever go up, forever down? Both of them. Yeah, they all do. So no matter what, your domain and your range is going to be all real numbers. All cubic functions and cube root functions.
Well, can you remind me, how's the domain and range between the original function and the inverse related?
They are interchanged.
Yes.
You interchange them, so the domain becomes the range of the inverse, and the range of the original becomes the domain of the inverse. So
Yep.
now they're exactly the same, so they stay the same, but they are interchanged.
That was one of the questions in your homework last night. Okay? This next one. I want you to take a second and see if you can go ahead and start it. You don't have to finish it. I want you to graph the original. You can either plug it in or you can put some points in, get some points. And then I want you to solve, but you don't have to graph the inverse yet. I want to see how you do. Some of you are already flying by, and it's awesome. If you want to keep going with it, you can. I'll give you like 2-3 minutes to work with your group if you need to. But number 9B, which is what you're doing, is just like 8C if you want to look back at your notes to see how to do the solving part. It has that radical in it. Except for you don't have cube, you have square.
Can you scroll it up so it's just two, let's see the full example? Well, like the two graphs together. That's like where. Yes.
Okay.
Good, thank you. So my
Which one? Yeah, we're gonna get there. We're gonna get there.
If this one was just a rough sketch of no
Yeah.
points, that's about what it would be. This starts here,
Yep.
does that. So this is the domain range.
Yep.
But if we do this here, this is down here, so that would make sense. Because negative.
Well, the range, yeah, it does make sense, but we'll talk about why it doesn't make sense. That's why I wanted you to hold off on that. Because when you're talking about the range, remember, it automatically was restricted in, because you have to go from your original function to the inverse, which is here. This is restricted.
Oh, it's not?
So this can't be the inverse, because it doesn't have that.
Oh, yeah.
Now this only has half of it.
So
Technically, it only has, yeah. Don't do the domain and range yet. I mean, you can try it, but I really want to make sure that you understand it. I'll explain it to you. So why? So then, yeah, she was right.
So, there,
Did,
you got that right. So there's that,
yeah.
that,
It's weird, isn't it? Yeah. So actually, don't graph the inverse yet. Just hold off. But some of you are having really good questions right now, and I love it. You're seeing something, and it makes me feel very happy. Okay, so really quick, just to make sure that your work is correct, go ahead and check your answers on this problem, and then we'll talk about the inverse graph because it's a little different here. So first, talk about, make sure that this is all correct first. Make sure your solving is all correct.
Guys, make sure you pay attention to either your exponent or your index on your radical. Okay, be very careful with that. You put in the wrong number somewhere, and you're gonna get something that's not right.
Okay, so what she means is like the square root is not 1, it's 2. So when you have to do the inverse, you're going to do squared. Just like we did with the cube root. You just got to make sure that you can transfer it to a new problem because it wasn't exactly like 8a, but it was very similar to it. Okay, now let's talk about the graph because that's really where people get confused. Now some of you put that in your graphing calculator and it looked like a parabola, correct? But our original graph looked something like this. Because that's actually what we're going to be getting into very shortly here next week. That's called a radical function. We're getting into that. That's our original graph. And if you notice, when you guys graphed it, it looked something along the lines of 1, 2, 3, something like this when you put in your graphing calculator. Right? Did I do that wrong?
No,
Nope, I did it wrong.
it goes,
I think I did it right. Your graphing calculator doesn't show you a parabola that looks like that?
Mine went.
Oh, down.
-2.
My brain. It was 2 o'clock in the morning when I was making my key. I'm sorry. All right. It looks something like this. Thank you. That's why I have you guys. Okay? I need you guys. I need my little math experts to help me. Okay, now, but that, someone actually said, but I thought the inverse is symmetric about the line y equals x, and they should look the same. It should be the same shape. You're correct. Which piece of my parabola is going to be the one that we use? The left side or the right side? The right side. So I'm actually just going to take a highlighter and highlight this piece. And that's what I meant by on a graph when we were talking about it on the homework. So like, for example, I drew this in. But then I put like a dotted line here so you know, like on your graphing calculator, you will see that. But only this piece is going to be part of it. Why? Because when we talk about our domain and range of our original function, which is in purple, what is the domain, left to right, of our radical function here? I start here and I go on. What's the domain? Good. -2 to positive infinity. So what must that mean then for the range of my inverse? What'd you say? I understand why you're saying that, because you're thinking like switch the x and the y's. But remember, the domain becomes the range of the inverse. So it's exactly the same, it's just being interchanged. You're switching them. And now let's see if that's actually true. When I look at my pink one here, is the range, bottom to top, does it start at -2 and does it go on forever? Yeah, so that you just validated that, so awesome. Okay, now let's talk about the range of the purple function, my original. The range, bottom to top. Where do I start?
0.
And I go on to, yes. So then what does that mean the domain must be of my inverse? 0 to infinity. Very good. And it validates what we just talked about. It has to be the right side. Okay? 0 to infinity. Left to right. If I go left to right, I start at 0 and I go on to infinity. So you just validated that. Do you have questions on that? That's one of the harder of the problems, including this next one that we're about to do. It says you try, but I want to do the next one with you. Not like solving the part, but I want to do the graphing with you because it's kind of the same thing, but backwards. So what I want you to do is to start solving this, because I want you to start solving for your inverse function, and then just stop there. Okay, so go ahead and solve that. I know this is challenging. Okay, they're solving for y. When you are done, and when you're done only, you can look up at my blue part. And I'll explain what's highlighted in a second, but just see if your work is correct. I'll explain what's highlighted in a second. Just make sure you have the work correct. Okay, so let's talk about this. A lot of you were flying through it. Good job. Yes, a lot of you got to this point, and you probably just had this. But remember, when you take the square root of something when you are solving, you have to have plus or minus, and here's why. Is 2 squared 4? Yes. Is negative 2 squared 4? Yes. That's why you have to have plus and minus when you do solving, and you have to introduce a radical into the problem. Okay? So, with that said, I kind of just wrote those out for you so that you can compare them. Okay? You don't have to write both of them out right now, but when you look at them, you have to look at your original function. So, I'm going to go ahead and show you what the original function looks like. I have my parabola, which I drew right here. So go ahead and sketch that in for yourself. Drew that in. I wrote this here, and I really want you to write this in and highlight it or circle it or star it. The inverse, this is exactly how your problem was that I went over for the homework. The inverse is not a function. Why? Why? Yeah, that horizontal line test tells me it is not a function because it crosses twice. So that means I must restrict the domain in order to have an inverse that is an actual function. You could pick either piece. Either one is 100% correct. When you start with a squared, you can pick either side. When you start with a square root, like we did in the last problem, you have to decide which one is correct. So you could have picked the blue one, or you could have picked the green one. It doesn't matter when you're talking about the domain and the range. Okay? So let's go back to that and graph it. Graph your inverse function. It looks like this. Again, when you put that in the graphing calculator, it does look like that. But we have to restrict the domain. Okay? And why is that? Why do I have to restrict the domain when it comes to a radical? What can't I have under a radical? The square root of something. What can't be under the radical? What kind of number? Not 1. Negatives. That's why you have to restrict it. If you typed in the square root of -2 right now, you would get an error. That's why we have to restrict it. This is like a challenging problem. We're not going to ask you this, but you need to be able to understand that you have to restrict the value. So, for the sake of time, the domain and range. You could have picked either one. That's your choice. Both of them are correct. Because you're not starting with the square root, you're starting with the squared. You could have picked either side of the parabola because you have to restrict the domain. Range is pretty easy because you go bottom to top. It started at 3, it goes on. Well, whatever one you chose, you switch and you interchange it. Yes? Only because if you do negative infinity to positive infinity, you don't have an inverse that's going to be a function. So that's a really good question. If you put negative infinity to positive infinity, I understand why. Because it is. That's technically correct. You're 100% right. But in order for the inverse to be a function, you have to restrict it to either piece. Pick one of them. It's like you're putting the restrictions on, not the problem. You are. You're putting the restrictions on so that when you do the inverse, you can have a function. Okay? That one's a challenging one. All right, I'm pretty sure Ms. Markowitz passed out her homework. Did you pass it out already?
I passed out the homework for my.
Okay, awesome. So you guys can go ahead and get started on that. And the keys.
That is your homework for tonight.
Oh, from yesterday, got it.